Good day everyone, welcome back to Cece's channel.
And to start this video, here are the things you need to remember. Sit, watch, and take down notes. Hey there future chemists, it's Jocelyn Cotara, and I am here to be accompanied by
Queen Catherine Cypress.
and we're here to help you to know all about the gas laws.
The gas laws are a group of laws that govern the behavior of gases by providing relationship between the following. The volume occupied by the gas, the pressure exerted by a gas on the walls of its container, the absolute temperature of the gas, and the amount of gaseous substances or the number of moles of gas. The three fundamental gas laws discover the relationship of pressures, temperature, volume, and the amount of gas. Boyle's law tells us that the volume of gas increases as the pressure decreases. Charles' law tells us that the volume of gas increases as the temperature increases. And Avogadro's law tells us that the volume of gas increases as the amount of gas increases. The ideal gas law is the combination of the three simple gas laws.
First in line in a gas law is the Boyle's law. In 1662, Robert Boyle discovered the correlation between the pressure P and the volume, inversely assuming the temperature and the amount of gas remains constant. Boyle's law is inversely proportional. The formula in the Boyle's law is P1 times V1 equals P2 times V2, where P1 is the initial pressure and P2 is the final pressure. The V1 is the volume initial and the V2 is the final volume.
The second gas law is the Charles law. In 1787, French physicist Jacques Charles discovered the correlation between temperature and volume, which is directly proportional to each other, assuming pressure and amount of gas is remaining constant. The formula for this is V1 over T1 is equals to V2 over T2, wherein V1 is the initial volume, T1 is the initial temperature, V2 is the final volume, and the T2 is the final temperature.
The third in gas law is the Gay-Lussac law. In 1802, Joseph Louis Gay-Lussac discovered the correlation between the pressure and the temperature, and pressure exerted in a gas directly related to Kelvin temperature. The volume and the temperature remain constant, which is it is directly proportional. The formula for the Gay-Lussac is P1 over T1 is equal to P2 over T2, where P1 is the initial pressure, T2 is the initial temperature, P2 is the final pressure, and T2 is the final temperature.
The next gas law is the ideal gas law. The ideal gas law was discovered by a physicist and engineer Benoit Paul Emile Clapeyron in 1834. The ideal gas law is the combination of the three simple gas laws. The formula for this is PV is equals to nRT. P is the pressure, V is the volume, N is the number of moles, R the universal gas constant, and T is the temperature.
Gas occupies 1.56 liter at 1 atm. What will be the volume of this gas if the pressure becomes 3 atm? So the given is P1, V1, and P2. The thing that we need to find is the P2, or the final volume. So the P1 is the 1 atm, V1 is the 1.56 liters, P2 is the 3 atm. We need to use the formula of the Boyle's law, which is P1 times V1 equals P2 times V2. So, the formula will be V1 times P1 divided by P2. We need to substitute the given. 1.56 liter times 1 atm divided by 3 atm will give us 0.52 liters. So the final volume is 0.52 liters.
Charles law. A cylinder with a movable piston contains 255 cm air at 10 degrees Celsius. At what temperature would you expect the volume to be 155 cm if the pressure is kept constant? To solve this problem, first, you should identify the given. V1 is equals to 255 cm. T1 is equals to 10 degrees Celsius, but you should convert it to Kelvin. So you will add 273.15 to 10 degrees Celsius. That would be 283.15. V2 is equals to 155 cm. With the solution V1 over T1 is equals to V2 over T2, it will be 283.15 Kelvin times 155 cm divided by 255 cm. Final temperature would be 172.11 Kelvin.
Gay-Lussac problem. If a gas in a closed container is pressurized from 12 atmosphere at 25 atmosphere and its original temperature is 32 degrees Celsius, what will be the final temperature? So the formula for the Gay-Lussac is P1 over T1 is equal to P2 over T2. P1 times T2 is equal to P2 times T1. T2 is equal to P1 times T1 divided by P1. Substitute the given. The temperature is needed to convert to Kelvin. So 25 atm times 305 Kelvin divided by 12 atm. This will give us the answer of 635.4 Kelvin. This is the final temperature. So the final temperature is 635.4 Kelvin.
Ideal gas law. Calculate the approximate volume of 0.400 moles sample of gas at 11 degrees Celsius at the pressure of 2.43 atmosphere. First, write out the givens. P is equals to 2.43 atmosphere. R is equals to 0.0821 atm mol K. N is equals to 0.400 mole. T is equal to 11 degrees Celsius. But we should convert it to Kelvin. So we will add 273.15. Then it will be 284.15. The missing is the volume. To solve for it, we will use the formula PV is equals to nRT. Then it would be V is equals to nRT over P. Write out the given. 0.400 mole times 0.0821 atmosphere mole K times 284.15 K. It will be 9.33 over 2.43, which is the pressure. The volume equals to 3.83 liters.
That is all about the gas law. I hope you learned our today's topic.
Remember, future chemists, think like a proton. Always think positive.